Today we study the Calculus 1. The topic is practical problems. In practical life, there are many practical optimization problems. How to deal with the kind of practical problems? The basic idea, step-by-step method. The practical problem is changed into mathematical question. How to do? Now look at the solving method, the concrete computation steps. Step 1. Draw a picture and assign appropriate variables. Step 2. Write a formula for our objective function. Write it as the Q. And then express Q as a function of a single variable. Pay attention to a single variable. Step 4. Try to find the critical points. Do you remember what is our critical points? Yes, there are 3 kinds of points: endpoint, stationary point, and singular points. And final step, try to determine the maximum or minimum. Pay attention to if in some practical question there is a unique stationary point about the objective function, the corresponding function value at this point is our desirable maximum or minimum. How to apply the following steps? So now look at example 1. Try to find the greatest volume that a red circular cylinder can have if it is inscribed in a sphere of radius r. So now look at the picture. It is our geometrical picture. So let corresponding the height of cylinder be double H, radius be r, volume be capital V. Look at the corresponding picture. This is our radius. This is our height, double H. This is our little r, corresponding radius. So now look at what is our objective function. Our objective function means how to get the volume. So volume equals basic area times corresponding to height. Basic area equals pi r squared times, where is our height? Yes, double H. So times double H, it is our V. How to do? Try to become the objective function is a function of one variable. By little r squared plus h squared equals capital R squared, we can get the relationship h and r. So V equals double pi h. Where is our little r squared? Equals capital R squared minus h r squared. So now our objective function is a function of one variable. And then pay attention to the domain h. H between 0 and capital R. Try to find the maximum point. What is? Try to find the critical point. How to do? Yes, V is a function of h. So V prime for h equals double pi is a constant. The first term r squared h prime equals r squared. The second term h cubed prime equals minus 3h squared. Corresponding, try to find it is our the V prime for h. Try to find the critical point. Let V prime h equals 0, obtain 2 points. One is positive, capital R over square root 3. Another is negative value. Pay attention to. Delete the negative value. Why? Because h is our height. Should be positive number. So negative value is deleted. So now, unique stationary point corresponding is our maximum volume, the point. So we can get the unique stationary point is capital R over square root 3 is our desirable point. It's our maximum value point. Corresponding maximum volume equals V equals double pi R squared minus little h squared. It is our final value. Pay attention to the example 1, how to apply the 5 steps. Write our objective function of one single variable. Try to find the stationary point, means some critical points, and then get the maximum volume. In the same idea, now look at example 2. The curved triangle region bounded by y equals 0, x equals 8. It is 2 straight lines. And another curve, y equals x squared. Try to find one point P. The P lines on y equals x squared, such that corresponding the triangle area bounded by the tangent line showing P, y equals 0, and x equals 8 is the maximum value. So now, how to write it? Look at the picture. In this picture, the pink curve means y equals x squared. The green straight line means x equals 8. This is our y equals 0. Together, passing P, do some tangent line, capital PT. So now look at the corresponding triangle region ABC. Try to find the maximum area. So now, as shown in the picture, let the tangent point P, x0, y0, we try to find the concrete values for the fixed point. How to write it? Look at the tangent line. The tangent line, capital PT. According to the point-slope form, what is our point? Yes, P, x0, y0. How about slope? Yes, slope means the slope value. So we can write it. Y minus y0 equals k. K means slope times x minus x0. What is our slope? Pay attention to P lines on the pink curve. How about the pink curve? Y equals x squared. Y equals x squared. Corresponding slope means double x. Taking the value means double x0. So it is the tangent line. So now try to get the P line in y equals x squared. So y0 equals x0 squared, satisfying this equation. Together, we can get corresponding intersection points. Corresponding A, half x0, 0. Corresponding C, 8, 0. Corresponding B, 8. Corresponding 16x0 minus x0 squared. So now we can make up the corresponding triangle region. How about the area? Yes, the area equals half times basis and height. And then we can get the area of triangle ABC equals half. This is our basis. This is the corresponding height. Together, write it this form. Yes, it is our objective function. It is a function of one variable, means one single variable. Pay attention to the domain x0 between 0 and 8. And then x prime for variable. What is our variable? Yes, x0. So prime x0 equals this equation. We can do it by ourselves? Yes. So now look at this form. S prime x0, let corresponding values equals 0. Try to find the critical points. So we can obtain 1 point x0 equals 16 over 3 and then equals 16. Look at the domain x0 between 0 and 8. So this value deleted. There is one and only one stationary point, means the unique stationary point. In practical problem, the corresponding maximum area is obtained at the stationary point, as the unique stationary point. So the point P is the final result, corresponding the maximum area S is the value, is our desirable maximum area. So in example 2, we're using the similar idea by the 5 steps. So now look at our summary. For our practical problems, how to do? Yes, the following steps to solve the practical optimization problems. How about 5 steps? Look at, do you remember step 1 until step 5? Step 1, yes. Draw a picture and assign appropriate variables. Maybe height, maybe length, maybe width. Means assign appropriate variables. And then write a formula for the objective function Q. What is objective function? Yes, you find the maximum area. Area is our objective function. The minimum volume, corresponding volume is our objective function. And then try to express Q as a function of a single variable. Maybe there are 2 unknown variables. Try to make the function into one single variable, and then try to find the critical points. How many points? Yes, 3 kinds of points: end point, stationary point, and singular point. The last step, determine the maximum or minimum. If there are more than 2 points, how to do? Compare the values. So now look at the following question and answer. The question is, a corresponding rectangular box is to be made from a piece of cardboard 24 inches long and 9 inches wide by cutting out identical squares. Pay attention to identical squares from the 4 corners and turning up the sides. Look at our question. There are 2 questions. Question 1, find the dimension of the box of the maximum value. Question 2, what is the corresponding volume? Means give me, how about the value? We have the following idea. Let x be the width of the square to be cut out, and capital V the volume of the resulting box. How to write it? Do you remember the basic idea? Write our corresponding objective function. So in this question, V is our objective function. Do you remember the basic formula? V equals the length times width times height. In this question, the original length is 24 minus from the 4 squares, so double x. So the length is 24 minus double x. Corresponding width. Width original is 9. 9 minus double x. So width is 9 minus double x. The height doesn't change. Corresponding volume equals length times width times height together equals this expression 216x minus 66x squared plus 4x cubed. It is a polynomial of x. Look at the variable x. It is a function of one variable x. X between 0 and 4.5 means the given domain. How to find? Try to find the critical point. So V prime for the variable x. V prime x equals 0. We can obtain 2 points. 1 point x equals 2. The other point, x equals 9. Compare the domain x between 0 and 4.5. So the 9 is deleted. So there are only 3 critical points. How many? 3. How to get it? 2 and points 0 and 4.5, and have another stationary point 2. Together 0, 2, and 4.5. 3 critical points. Determine which value is maximum, so we can get corresponding V0. V0 means 0 taken in 0, 0, 0. Together, volume equals 0. The value V at the point 4.5, kick in the value, equals 0. V, the value at the point 2, taking in the stationary point 2, the final result equals 200. Now, compare the 3 values, 0, 0, 200. Of course, 200 is the maximum. So, corresponding x equals 2 is the final result. Corresponding volume is 200. The box is 20 inches long, 5 inches wide, and 2 inches deep, corresponding 3-dimensional. So now, the class is over. See you next time.